All right, so let's continue to do some of these problems. For problem number 4, these are like discussion problems. I might even just type these. We'll see. It says discussion. What would be the reason for isolating a variable in a literal equation? I'm going to say maybe you want to solve for one specific parameter. Okay. Example. Maybe so. Hey, quit talking. Pay attention. By the way, you're supposed to be writing this down. Yeah, I don't know what happened. I paused for 10 seconds to get the next video ready, and you just went on free time. So it says, what could be the reason for isolating a variable in a literal equation? And I said, maybe you want to solve for a specific parameter. So in this last problem, what we did is we solved for m. What does m represent in the linear equation for slope-intercept form? What does this represent? It represents the slope. For example, maybe I know the x and y values of a graph, including the y-intercept, then in parentheses I'm going to put b, but I need to find the slope m. In other words, we're used to seeing y equals mx plus b. We plug in an x value, that gives us the y value, but maybe we know a point on the graph and we know the y-intercept, and we want to figure out what the heck is the slope. Well, we just created a formula that if I know an x and y value and the y-intercept or the b value, I can plug it in and it'll tell me the slope. That's kind of cool, huh? What do you think? So that's one example, okay? So for number 5, it says, describe a situation in which the formula could be used or more easily if it were rearranged. Include the formula in your description. How about area of a circle? So the area of a circle is the area is equal to pi. Well, let's not do a circle just because I don't want to type pi. Let's do the area of a rectangle. Is equal to the length times the width. Or I'm just going to say LW. If I know the area and the length so if I know the area, this is A, if I know the area, which is capital A, and the length, which is capital, or not capital, lowercase l, I can find the width, W, if I rearrange the formula. Let me start this over here. if I rearrange the formula to W equals the area divided by the length. So let's say Mr. Adams has to put, for whatever reason, I know the area of a rectangle and I know the length of the rectangle and I got to measure out the width. Maybe I'm putting fence around somebody's yard. Maybe it doesn't matter what the reason is, but maybe I got to do it more than once. So I just rearrange the formula since I know what A is and I know what L is, and I just plug it in. Does that make sense?
Yeah.
So essential question, how do you isolate one variable? I'm going to say you move things away from a variable by doing the inverse operation. That's it. You make it look like x equals some stuff. If you're adding to x, then to move whatever you're adding to x, you just subtract it from both sides of the sequel. You just whatever you do on one side, you do to the other side. And remember, you are using the properties of equality. So if I add to both sides of the equal sign, then that's the addition property of equality. If I'm subtracting from both sides, that's the subtraction property of equality. Okay? All right, so we're going to pause that video there.